Welcome back to KhemWithKess, where we'll be discussing nucleophilic addition for aldehydes and ketones. And the name of this reaction is called hemiacetal. Now, hemi itself means half. So in this reaction, we're going to get a half OH group and a half OR group. If instructors ask you what functional groups does a hemiacetal create, one is going to be an alcohol, and the other one is going to be an ether, is what we're creating out of this reaction. This is going to be considered acidic conditions when we get ready to talk about our mechanism. And again, instructors can write this in a more expanded form where they're writing out the CH2s and CH3s, or they can write it in the skeletal format. For the actual acid itself, it could be recognized as the H3O plus, the H plus, or even like H2SO4. So with this reaction, the quickest way to get the answer is, again, writing the base of your structure. Once you have your base written, where does the reaction happen? At the carbonyl. You should be sick of me saying this. And then in this reaction, again, since half is going to be an OH, we know half is going to turn into here. So really, it's almost like thinking about the carbonyl's oxygen actually ends up becoming the OH group. But then, or another way to look at it, which I tend to do this a little bit more for students, I highlight this hydrogen in red so students know that that's the hydrogen that is going over to there. And then the remaining portion that's left over being the OR group, so O and this isopropyl group, that is what's going to get added to the other side. So that's going to be an oxygen, and the first one has 2 carbons, so you can continue drawing it like the CH2, CH3. However, if you also wanted to draw this, this one was not an aldehyde to start with, it was a ketone. So this one can also be written as the OH and the ethyl group, or the one on the bottom will have the isopropyl group like this. So just remember when you're doing this problem that you clearly denote that you're going to get a half OH and a half OR group split at the carbonyl center. Let me know if you have any questions.